So Rick Mathen is here. He's the General Service Officer for the U.S. Consulate in Guayaquil, and he's been here for 4 months. He's going to be in Guayaquil for 3 years, but he's no strange to flying and to looking at the stars real close, because he was for 27 years with the United States Air Force, and we are very glad and we're very honored to have Rick here. And Guayaquil, actually, the first consulate that we had was the U.S. consulate, and Guayaquil is one of the first cities in the whole South America with a consulate. We actually started a U.S. consulate before Ecuador was created in 1824. William Wheelwright was the first consul general in Guayaquil. So with that, we welcome Rick Mathen. Rick, thank you for being with us.
Muchas gracias por su cálida bienvenida. Tenía muchas ganas de poder dar mis comentarios esta noche en español para ayudar con mi fluidez, pero el señor Ayón insistió en que este evento debería realizarse en mi lengua materna para promover el idioma inglés reconocido internacionalmente para la aviación y el espacio. So, here we go. It is a tremendous honor to be here with you tonight, representing the United States diplomatic mission in Ecuador. I am very humbled to be giving remarks alongside all of you space advocates, and I want to thank particularly Mr. Ayón, CEO of Leviathan Space Industries, for the invitation to speak to you tonight, as well as all those involved in the organization of this event to celebrate the first anniversary of the Guayaquil Space Society. And I understand that congratulations are in order, not only because we are marking the first anniversary of the Guayaquil Space Society, but also because we are recognizing your leadership and your pioneering spirit. You're the only active chapter of the National Space Society in South America, and I congratulate you on this achievement. And I'm sure this is only the start of something wonderful. It's an exciting time, as you know, for space travel, and as an American diplomat and former pilot in the United States Air Force, I am proud to see my country rejuvenating its leadership role in the final frontier. And just as importantly, the United States understands that it needs capable partners to join the pursuit of possibilities in space. And through organizations like yours, Ecuador is clearly showing the world its potential and desire to explore above and beyond the limits of our stratosphere. I'd like to spend just a few moments setting the stage for what promises to be a very informative evening, by telling you just a bit about myself, along with highlighting some of the significant accomplishments of recent U.S. efforts in space, which will subsequently help to open up new opportunities to countries like Ecuador, and more specifically to organizations like the Guayaquil Space Society. As I mentioned briefly, before becoming a diplomat representing the United States abroad, I served in the U.S. Air Force as a pilot. For 27 years, I made a career of flying aircraft such as the T-38 Talent, which should bring a smile to those in NASA, as it's been the aircraft used by astronauts to maintain their flying proficiency. The C-130 Hercules and the C-12 King Air. Immediately after retiring from the U.S. Air Force, I flew for Delta for a short time, and I also flew as a defense contractor in Afghanistan, where I taught young Afghan Air Force pilots how to fly the PC-12 aircraft. During this long career as a pilot, there was a significant period of time when I wanted to become an astronaut. As an Air Force pilot, the road to becoming an astronaut was a long one, but I saw it as an achievable goal. The first step was to become a test pilot. In the Air Force, becoming a test pilot is a very competitive process. And at the time, the requirements were to be a pilot with an engineering degree, preferably a master's degree. I met those requirements, and so I decided to apply. I was unsuccessful, but despite my bruised ego, I decided to try again the next year when I was denied a second time. So I moved on in my career, giving up on my dream to become an astronaut. But to this day, I often wondered what it would be like. And for many of you, this dream can and should be alive today. There's so much cool stuff that's been accomplished in the history of space travel and exploration, and today, the possibilities continue to be endless, but are much more readily available. I'm excited to see you all as space enthusiasts reaching for the stars in fulfillment of your dreams. So, why does space matter? A question many people ask. Shouldn't we just focus on taking care of our own planet rather than trying to find life on others? Well, as we know, there's much more to space exploration than just trying to find life beyond planet Earth. In fact, many of the things we use in everyday life are direct spin-offs from innovative designs first used in space. From cordless vacuums to ventilators, from memory foam to high-tech Speedo swimsuits. Many things initially designed for life in space have later become routine items that we've incorporated into daily life here on Earth. The fact is that our efforts in space have significantly improved our quality of life on this planet. And there are so many more possibilities out there, which is why it's so exciting to see the United States leading again in space. Interestingly, the U.S. State Department, my current employer, was a pioneer early on in promoting space exploration. As early as 1967, the State Department brought together the Soviet Union, the United Kingdom, and the United States governments to sign the Outer Space Treaty. This treaty turned out to be the cornerstone of international space law for over 50 years. Imagine that. The Soviet Union and the U.S. governments agreed on the terms of such a treaty in the middle of a Cold War and a space race to get to the moon. Today, the State Department has a new focus on space diplomacy. It involves the promotion of the commercialization of space. These efforts are led by our U.S. science envoy for space, who happens to be a former astronaut. The commercialization of space is important. While space exploration may have been more effective under the auspices of the U.S. government back in its infancy, the reality is that it comes at a high cost to the taxpayer and lacks the competition that commercialization provides. That's why it's so awesome to see the partnerships developing between government and the private sector. The recent launch of the SpaceX Crew 1 to the International Space Station is a great example of the synergy that exists when various nations collaborate and combine the strengths of governmental funding along with commercial innovation. This time, the crew consisted of US and Japanese astronauts, but next time, why not Ecuador? Although commercialization of space has become the new normal, the US military has recently shown its desire to rejuvenate its efforts in the final frontier. While the US Space Force may sound like something out of a science fiction movie, this new branch of the military is a reality today. Born from the Air Force, much like the Air Force was born from the Army in 1947, the establishment of a Space Force in the military is a clear signal the United States recognizes the importance of preserving the peace in space for all to access. Undoubtedly, the Space Force will play an active role in the Artemis program, which ventures to achieve the long-term return of astronauts to the moon by 2024. Wow. Establishing a colony on the moon. Can you imagine? The United States realizes it can't do this alone. So this ambitious program will require many partners to be successful. And again, why not Ecuador? Indeed, why not Ecuador? Especially given the events of last week, where the government of Ecuador signed the declaration for the creation of the Latin American Space Agency. At the signing ceremony, Foreign Minister Luis Gallegos commented on the relevance of having a permanent intergovernmental regional mechanism to strengthen capacities in the space field and promote coordination and cooperation among national, regional agencies, academic institutions, non-governmental organizations, civil society organizations like the Guayaquil Space Society, and the private sector. Sounds like a great start for Ecuador to emerge onto the world stage when it comes to space exploration. I want to conclude by again congratulating you all on this significant milestone in the history of the Guayaquil Space Society, your first anniversary. While the leadership of Mr. Ayon and your collective bright and innovative minds, I have no doubt this will be the first of many anniversaries you will celebrate. And I look forward to watching you grow over the years and wish you all the best in achieving your personal dreams while furthering the mission objectives of the Guayaquil Space Society and beyond. On behalf of all of us at the U.S. Mission in Ecuador, good luck and Godspeed. Thank you.
Thank you. Thank you so much. Great from the U.S. Consulate. And it was 2020, the year where Guayaquil welcomed you. And you just mentioned maybe 2024 and why not Ecuador? Well, 2024 would actually be 200 years to the date of Guayaquil having a U.S. consulate. So wouldn't that be wonderful? Celebrate our 200 year together on this wonderful phrase of why not Ecuador? Why not Ecuador? Why not Puerto Rico? Can somebody from Puerto Rico who was born in New York become an astronaut or become an engineer or work for NASA? Well, somebody said, maybe you shouldn't. And he said, no, STEM can help me. STEM meaning science, technology, engineering, math, and actually pave the way. And that's what happened to Stephen Gonzalez. Stephen, thank you so much for being with us. And here we are to learn from you. Stephen Gonzalez was born in New York City. His family is from Puerto Rico. And he worked until recently, until August 2020, for 32 years at NASA, doing a lot of things. And then, of course, he can't stay still. So here he is, talking about NASA and all the wonderful things that we can learn from the technology, how to use it for different industries, how to help the world with what we learn, and how to inspire students and world leaders to look beyond, just like Rick said. Stephen Gonzalez, welcome so much.
Thank you guys. Thank you so much for that wonderful introduction. Let me see about sharing my screen here.
So Kurt, if you can help Stephen so he can share his screen, that'd be wonderful.
Can you see it?
Not yet.
Okay, all right, hold on a second.
Well, in the meantime, let me tell you guys a little bit more about Stephen Gonzalez. He has trained astronauts. He studied at Harvard Business School, also UCLA Anderson School of Management. He has a Master of Science in Computer Science, Texas A&M University. And something that is really interesting is that whenever you put science and heart together, you have somebody working in different industries. And one of his later places where he's worked is with the survivors games. And we'll learn a little bit more about that when Stephen shares with us. Thank you so much, Stephen. So now we're able to see the screen.
Excellent, thank you, Karina. So thank you again for giving me the opportunity to be able to share with you a little bit about the 32 years and to expand on the comments that were just made as how amazing this time is for students that are graduating, that are looking to see what's possible. Because you see, I joined 32 years ago to be able to get to this place, be able to explore where no one had gone before. It was actually Star Trek that got me hooked. And I wanted to be able to reach these far destinations and to dream big dreams. And so this evening, I hope you walk away with 3 ideas from my talk this evening. The first one being that never to fear dreaming too big. Let your imagination guide you and let your imagination be the North Star that allows you to create a vision and a future like you see here in the painting. Secondly, don't let anyone ever tell you that you can't do it. Don't let anyone ever say that it's not possible. And I'm sure, as Karina told you a little bit, my story of how they tried to stop that dream for me. And then finally, please take away from what has already been said as far as how amazing this time is for space opportunities. When I joined 32 years ago, the NASA, for the most part, was the only game in town, was the only thing that you could join. There were contractors that supported NASA, but now there is so much going on. As we just shared, there's so much in commercial space, so much internationally, so much that's being done. And if space is not what you want to do, if space is not what you're passionate about, then hopefully I can offer you a path to take what we do in space and to transform life here on Earth. And so with that, as Karina has said, my family is from Puerto Rico. Come on. There we go. My father is from Jayuya, and this is where the pictures are taken. My mom is from Arecibo. And this is my second birthday in Puerto Rico. My great-grandfather was from Spain. My great-grandmother up in the left-hand corner was a Taino Indian. And it was from these humble backgrounds that sets the foundation, sets the roots, sets the pride and the drive that I have received, and the support and foundation that allowed me to be able to do the things that I wanted to do. I remember the story that my grandfather loves to tell my daughter and my son about how when he was growing up in Puerto Rico, he didn't have a pair of shoes until the third grade, because in his family, if you couldn't pay for your shoes, you didn't get it. So finally in the third grade, he got his first pair of shoes, but up to then he was walking an hour each way to school with no shoes. And when he got his first pair of shoes, that was the last time he went to school. From the third grade on, he worked the rest of his life. And so with that, my parents came to New York when they were young with a vision of being able to provide for their families something better, something that would allow them to be able to reach for the stars. And so they moved us to New Jersey, and in New Jersey, we were the second family, Latino family there in New Jersey, in the community that we were at. And I was ready to be the first one to go to college. I was ready to be the first one to be able to go study computer engineering. It was in the 8th grade that I had the vision of going to NASA. It was in the 8th grade that I had decided that I wanted to chase that dream. I wanted to be Captain Kirk. I wanted to be able to be on the deck of the Starship Enterprise. And I remember in the 8th grade when I went to the guidance counselor with my classes for high school, she looked at them and she says, "These classes prepare you for college." And I said, "Yes, I'm going to be the first one to go to college." And she looked at me and she knew that I was a New York Greek and a Puerto Rican from New York. She knew my last name. And she said, "I don't think so. I think you consider a career as being an auto shop or auto repair. College is not right for you." And luckily, as I said before, it was my family. It was this foundation that gave me the belief in myself to not listen to those others, to not listen to the advice of people that only saw me for my name or for my heritage, but didn't know what was possible. And so I ended up going to Boston University, getting my degree in computer engineering, doing my graduate work at Texas A&M. And when I completed my degree, I was expecting to work in NASA, but as my second career. I thought my first career got a couple of things. So,
yo lo estoy paniqueando demasiado. Que menos mal, yo no sigo.
Thank you. So at the end of my college career, I was planning to work at NASA. But first, I had planned to go back to New York, leave Texas and go back to New York, work for Bell Labs, and do NASA as a second career. And Bell Labs offered me a whole lot of money to go work for them, a lot more than working for NASA. But I was so close to my dream. I was here in Texas with my soon-to-be wife, and I couldn't let go of the dream. And so I waited. I turned down the position at Bell Labs, turned down making more money, and stayed in Texas for about 4 months until the money ran out. And I called back Bill Labs and I said, is the position still available? I'd like to come work for you. And he said, absolutely. We'll work the paperwork tonight. We'll give you a call in the morning and finalize the deal. So in the morning, I get a phone call. And there's a young woman at the other end of the phone said, hello, this is NASA. I'd like to know if you'd like to come work for us. And so I shared that story only because I almost gave up my dream for money. I almost gave up the passion that I had to be able to get a higher paying job. And my advice to you, to the students that are here this evening, to hold on to that passion, hold on to the dream, to continue to pursue that. Because what ended up happening was that I ended up going to NASA in the spring of 1988. And my expectation was I was going to work on mission control, and I was expecting this. I was expecting the deck of the Starship Enterprise. I thought that 20 years after us landing on the moon, they would have these fancy computers, the fancy rooms. But unfortunately, when I got there, it looked like this, 20 years later. And it was my dream to be able to be on the deck of the Starship Enterprise. And I knew one day I would get there, but this is what I started off with, bringing new technology into mission control. I was bringing in new workstations and new equipment to allow the flight controllers to be able to bring our astronauts home safely. And from there, I ended up working on a project to be able to model the network from mission control up to a vehicle that was still in the drawing board, which is the International Space Station. It was a vehicle that is about the size of a football field. Right now, it has 7 astronauts up there on the vehicle. You heard some of the stories and that. And so I was able to do that for a couple of years. Then eventually ended up, as Karina said, training astronauts. I had a dream to become an astronaut. I had thought about it, but as I considered the life that they led, considered what it is to the sacrifices they've made, and the family that my wife and I were starting, and how much I would be away from them, I wasn't willing to make that sacrifice. But I trained them. I trained them on the computer systems. I trained them on the systems to land the shuttle. And what was wonderful about this, and the gift that NASA gave me, was that when you train astronauts, you get to see them launch from Florida. But the date of their launch was the same time that my wife was due with our first child, was expecting our son. So I stayed back behind for that. But then the crew was still up in space, and they heard about the birth of my son. And they called back down and said, Houston, this is Columbia. We'd just like to congratulate Gonzalez on the birth of his son. So I got that as a gift from them, and it's something that our family always treasures. And then finally went back to mission control and was able to achieve the dream. I was able to work with the team to be able to create the deck of the Starship Enterprise. It's funny, when we finished the project, when we transformed the room, the newspaper here in Houston compared it to the deck of the Starship Enterprise. So finally I figured after 8 years, I achieved my dream. But it was about this time that all of a sudden I had to step back, because up to this point, I had been chasing leadership roles. I had been chasing the path to be able to move up in NASA, to be able to be in that top management position. And I realized when I went to this leadership seminar that something was missing. At this leadership seminar, this gentleman had showed a video that showed a gentleman wanting to be surrounded by people that are passionate about what they did, and he wanted to be passionate about his own work. And so this gentleman, who was a violin maker, went to Italy, to the town where Stradivarius had made violins, and was there working with people that loved what they were doing, and he was excited. And I came back home and I told my wife, it's been almost 10 years and the passion's gone. I've been chasing after the promotions. I've been chasing after the higher roles, the higher pay, and I've forgotten what brought me here to NASA in the first place. I traded the position for the passion. I traded moving myself up in company and forgotten about all those others that were seeking for the same opportunities. So she asked me, okay, so what are you going to do about it? And I gave myself a year to recapture my passion. And in that year, I wanted to get back into technology. I wanted to be working on advanced technologies. That's why I went to NASA. I wanted to be able to help out the other Latinos that are coming into NASA, and those that were looking to graduate and come in. And I wanted to be able to be surrounded by people that are passionate about what they did. And thankfully, in a year I was able to accomplish that. And one of the things I did was create a technology lab in mission control, and I commissioned in that lab this painting, which in the painting, what I love about what the artist had done was put this child in the faceplate of the helmet. And I don't know if you can see it on your monitor, but hidden in the background of the helmet is the face of Albert Einstein. And I love this quote from him because Albert Einstein knew the value of education. If it wasn't for his education, he wouldn't have been able to come up with all the technologies and all the theories that he brought forth and transformed life as we know it. And yet, even with that, he knew the power of imagination. And the artist captured that here. He realized that it was the imagination, it is the faith of a child that will allow us to be able to reach to the stars. And so as you're going through school, as you're looking to graduate, as you're looking to whatever way that you want to transform life, either here on Earth or in the stars, hold on to that imagination. You know, at NASA, we always use the term, you turn science fiction into reality. And so now in this new world, I'm hoping that not only can you turn science fiction into reality, but many would think would be magic, that you can use it to be able to transform life here on Earth. And so this imagination is what's going to change the landscape of space. And it has. As was just mentioned earlier, the commercial space community is doing things and building on things that NASA started that we hadn't dreamed of and wish we had done. And this next video is one that always sends chills down my spine because of what's possible because of someone that imagined something that is incredible. So with that, let me play this video.
It's a god-awful small affair to the girl with the mousy hair, but her mommy is yelling no, and her daddy has told her to go, but her friend is nowhere to be seen. Now she walks through her sunken dream to the seat with the clearest view, and she's hooked to the silver screen. But the film is a sad thing for, but she's lived it 10 times or more. She could spend till the eyes of fools if they ask her to pose for some sailors fighting in the dance hall. Oh man, look at those cavemen go. It's the pinky of shadows. Take a look at the long tail leading up the wrong guy. Oh man, wonder if you'll ever know who's in the best of these shadows. Is there life on Mars?
It is that double landing at the end that is always gets me. I've seen that a few hundred times, and every time seeing the accomplishment, seeing the imagination of those engineers, recognizing that technology will allow us to land on Mars. That technology will allow us to be able to land our astronauts there, and to see it actually happen and see it happen at the simultaneous is a miracle. It's a miracle of science, miracle of innovation, miracle of imagination. And so that has exploded the opportunities for new companies to get involved. You have Blue Origin, Jeff Bezos from Amazon has his space company. You have a company called Intuitive Machines that's here in Houston that is building a vehicle to be able to send payloads to land on the moon. You have Blue Origin and a number of other companies that are looking to put a human lander on the moon. You've got Alpha Space here, a small startup company. You have companies down in Brownsville, Lunar Station, and others that are wanting to be able to help make space reality for everyone, not just for the few hundred astronauts that NASA has sent. But again, if space is not your passion, if space is not what you're wanting to do, then I hope that you'll join us in one of the projects that NASA does in order to be able to transform life here on Earth. And in this one here, it is the project that was the last project I actually did before I left NASA. And I was working with Robert and Guayaquil Space Society to be able to take technology that we had developed to protect the astronauts as they went onto the moon. It's known as the human powered ventilator. So as the astronauts were going into the moon, and if anything should happen and they weren't able to breathe, we created this technology that didn't require any electricity to be able to make sure we could provide oxygen to the astronauts. And so back at the beginning of the COVID crisis, I asked Robert if he would help me being able to bring this technology to Ecuador, to be able to bring it to the Latin American countries to be able to help reduce the impact of the COVID on the population there, to be able to provide a different technology to help with the breathing challenges for a lot of the patients. And so Robert and Guayaquil Space took on that challenge, and they've been working all summer to be able to harness the resources of different companies there in the region and in Brazil to be able to bring this to the community. And it's going to transform the possibilities for healthcare, not only in Central South America, but also in Africa and in Asia. And it's because of the vision and the dream of Robert and the people that he's able to bring on with him that will make it happen. And what I see as needed for this are students with a passion, because in South Texas, we have done this with students. It's an organization down there in Brownsville called Rockets and Rigs. And in this organization, we were looking to be able to take space technology and help out the energy industry. And what I love about this event that we did last year was that we brought together entrepreneurs, engineers from the energy industry, engineers from space, venture capitalists, and all these students at Brownsville to look at 10 technologies and try to create 10 companies. And what you see here are the students in each one of these teams. And a year later, 3 of these teams are launching with students as the CEOs, students as the presidents, students as the chief technology officers for these companies. And they're going to transform life here on Earth, and they're going to create more opportunity there in Brownsville, because they took their technology, they took their education from the university, and they're going to impact the lives of the people that live in their own neighborhoods. And so what happened here in Brownsville can happen everywhere. And for those that, as you heard, there's so much going on there through Guayaquil Space, and Robert can connect you. But there's also activities going on in Puerto Rico. And back in last November, I went to Puerto Rico to visit with Parallel 18. Great organization that every year will do a call out to all of the countries in the Americas to be able to see who's got a technology, who's got an idea that they want to be able to create a company. And they invite them to Puerto Rico, and they work there for a few months to help them launch the company. And this last year, we were going to try to do the same thing in Puerto Rico, reaching out to the whole community to be able to move NASA technology and create companies that would transform life throughout Central and South America. And we almost got there, but of course, COVID shut it down. But I know that team is still wanting to do it. So I would ask you to keep looking out to what's going on in Parallel 18 to see what's possible, to see if you might be able to one day work with them to move technology to create new industries and new markets in your community. And we've done things with New Mexico, with the community out there to be able to help them grow companies. And up in New York, they were actually, in the New York Space Alliance, they were creating companies down in Brazil with technology that came from NASA. So that's possible. It's up to you and your imagination and your drive to be able to pursue and to make it happen. And so finally, I hope that as you graduate, as you go into your careers, as you look forward to seeing what's possible, that you remember to follow your imagination. Don't let anyone ever tell you that it's not possible. Don't let anyone ever tell you that you don't have the skills, you don't have the ability to do it. And please remember that the opportunities out there are endless. The future is wide open. And if you are willing and wanting to, please help us make this vision a reality, and maybe even be one of the people that steps foot on Mars and looks at this incredible view. And with that, thank you so much for your time.
Thank you so much, Stephen. Here we are clapping for you. Everywhere.
Thank you, Karina.
Incredibly inspiring, and sometimes as children we hear is listen. Well, don't listen. just go for your dream. If you need to listen to anybody, just listen to Stephen Gonzalez. He said, "Hey, go for my dream." And it's incredible when you mentioned about art, because we think of STEM, and sometimes we forget about STEAM. That's science, technology, engineering, arts, and math. And for us poets who look at the moon and the stars and see beyond, and for artists, we need to realize that that is also an industry that can be widely changed by what we learn and by what we investigate, and also how we can utilize whatever inventions are available from what the space can bring us. Now, sometimes when we talk to students, or when we talk to children or grandchildren, we say to them, well, make sure that you study something that can be easily transferable. So, for example, if you study law and you live in Ethiopia and you're a lawyer in Ethiopia, basically you're limited to that. Now, if you learn how to cook or how to be a healthcare worker, you widen up your dreams. But if you're able to work in science and math, then there is no limit. There isn't even a limit within the Earth. Space is out there for you. Today is the 24th of November. Tomorrow, November 25th, is the International Day for the Elimination of Violence Against Women. If women can use our education to leave a toxic relationship, it is survival. So don't just think about education as a way to get your dreams. It's also a survival technique. And thank you so very much, Stephen. We're gonna go on with Leonardo Guzman now, and after Leonardo, we'll welcome students from ESPOL, and then we'll open some questions, which I'm sure there are many questions out there. Thank you so much, Stephen. Big round of applause for Stephen. Leonardo Guzman was born in Venezuela, and he studied architecture at the Universidad Jorge Tadeo Lozano, Jorge Tadeo Lozano in Bogota. And he's also one of those people who said, well, I can go beyond. And just as Stephen was saying, that there are places that can be constructed in space, well, Leonardo Guzman is one of those people who can actually build those places somewhere. You just name it. He's actually, he has a Master's of Science degree in space. Right? So, working with CAD, actually, was it your your thesis, Leonardo, that you presented it at the International Conference of Environmental Sciences, and that's another thing. Sometimes we see countries with several challenges, political challenges, economical challenges. But then again, science can get you out of there, and Leonardo is living proof of that. So with that, we welcome Leonardo Guzman. Thank you so much, Leonardo.
Hi, hello everybody. Hola a todos que hablan español. And speaking with Robert, we're gonna tape this and put it out on YouTube with Spanish subtitles. So vamos a montar este video con subtítulos en español para los que no escuchen muy bien o entiendan muy bien inglés, para que podamos todos ver lo que hemos dicho hoy. So yeah, I'm gonna start presenting. Second. All right, are you able to see it here? Okay, perfect. All right, so from architecture to space architecture. So how Karina was saying, I studied architecture in Bogota, Colombia. And in a period of around 2 to 3 years, I had this change in my mind that was kind of rapid, and I call that a creative explosion of some sorts, where I was, say, in the middle of Bogota in a relatively little art school studying architecture, and I was going on the bus, and 2 years later, I'm designing space stations and talking to astronauts, which is kind of a shift that not many people do, but it happened to me. Since it happened to me, I want to explain kind of how I got there and my process to it. So this is an image of my master's thesis, which I also expanded on for the International Conference of Environmental Systems. Essentially, an optimized space station in low Earth orbit. Low Earth orbit is called as LEO, so it's Leo, so there's that ongoing thing that's my name too, but coincidence. Essentially, this space station took the form of the rockets. I don't know if you, in looking at Stephen's SpaceX launch, the fairings are the top part of the rockets that reach orbit. So my proposal is to actually pressurize these fairings and reutilize them as large space stations that can function in low Earth orbit. So going into my history, I was studying civil engineering for 2 semesters in Bogota and Universidad Javeriana, where, like a lot of people, a lot of students nowadays, you start a career and you're not really sure what you want to do. And I wasn't sure, so my mind was always ranging from drawing, so I like the arts, I like architecture, but I also like science and engineering. So I was in civil engineering for 2 semesters, and in being there, I decided, hey, I think I want to create. So the civil engineer, he builds for the architect's idea. So I was like, what if I get the first idea and then see how it's built? So from that scope, I transferred to Jorge de Lozano University, a smaller school, where my mind started to realize that the full scope of a building or a construction, if you think about it, an architect, he sees the whole of whatever he's creating, and then from that whole he makes subsystems. So subspaces, you have to understand how the structure of the building works, you have to understand the plumbing, have an idea of how the electricity is moved around the building, and you look to optimize. So essentially, people talk about how design is, or the arts are purely aesthetic principles. What I say always is that design is actually an optimization tool for different systems. So after Latadeo, I came to the United States, back to Houston, because I used to live here before, and studied a Master's of Science in Spanish Architecture. But you're saying, wait, there's a jump here. Like, how did you make this transition? So back to when I was on the bus, I started to understand that in order for you to understand, to work in different fields, you have to have the two sides of the brain. Usually these are the diagrams that we're all shown, where we have both the right and the left side of the brain. Each one is logic and the other one is creativity. But it turns out that there's this part, this is my favorite part of the brain, which is kind of a weird thing to say, but there's a corpus callosum, which essentially is the center part of the brain that connects the two hemispheres. So both of our hemispheres work together. What happens in education, in conventional education, is that in studying one specific field, we get hyper-focused on one specific type of subject. And that essentially kind of takes apart one side of our brain. So I was thinking, if we have this connecting piece, what if we can optimize both sides of our brain so that they start working together hand in hand? So you can be a scientist and like Albert Einstein and play the violin. So I know his what he's wearing is not the most nice tuxedo, but it doesn't matter. What I'm trying to say here is that he was one of the smartest minds that we've ever had. He's one of my idols, Albert Einstein is. And during this time, I decided that not only studying architecture, I wanted to learn a lot of things. So I started learning physics on my own, because I understood that when studying architecture, I wasn't going to get the full scope of things. I was going to get an overview of how a building works, but I also wanted to understand the engineering side of things. So I started to investigate on engineering, physics, even chemistry. I would read some books on, and I was even about to start studying physics when my brother called me one day. He's like, hey, there's this program at the University of Houston that's called space architecture. So I looked at it, and then I applied and I got in. So a little bit of my work during architecture, essentially you have to design plans and facades and see how buildings are distributed. So it's essentially, architecture is a good place to be, because it's a center between both design and more logical aspects of construction. So in architecture, you have to take into consideration sustainable design principles. So, for example, how much hours of sunlight each side of a building gets, and how do you distribute that direction for it to receive the most or least sunlight, depending on how hot or cold the environment is. So, for example, in this project, I decided to work with greenhouse heating. So there was an interior volume. These were student housing. This is a student housing project where I did two layers of walls. One had glass on it, and essentially these patios, they became kind of like a greenhouse. So the hot air would come in, would get diffracted by the windows and produce heating. And since a lot of us, well, the people who have been to Bogota know that it's kind of cold and it rains a lot, heating up the sides of the rooms was like an important thing. So you would also have to think about the circulation of the wind. So how are you going to solve for that? So there's all these variables that you have to solve for. And when I got to space architecture, this was very key, because in space architecture, you have to deal with different type of variables, but they're essentially variables. So the way of solving a problem for space is analogous to how you solve a problem for architecture. So it's these jumps of one field to another, and what concepts can you take from one and apply to the other, and that generates new types of solutions. So it's a multidisciplinary focus. So they teach us how to perceive objects as a whole. Buildings are essentially volumes. And we have to understand how each part of the building is connected. So what happened, something weird started happening, was that in studying these type of isometric views and exploded views where we get all these details, I would be on the bus on my way home, and then I would start looking at a bicycle, and then I kind of, in my mind, kind of exploded. Yeah, not exploded. Well, like separated into different pieces. And I wouldn't have to know much about bicycles, but in doing that, for every type of object, I started to get an understanding of how things would work. And if I was very curious, then I would get home and then I would investigate some more. So that's essentially a trick that I started doing. And I would do that for, let's say, vehicles too. And I was in this mechanism where my mind was starting to race a little bit more. And as I applied to the program, I never left the arts behind. So in understanding how, let's say, buildings worked, I would do them by hand. So with one drawing, I would try to generate a functioning module. So it would be a blank page, and then I would start from 0, and it would be 1, 2. And then after this, I started working in animation. So add time into the equation, and then a drawing could become a whole series of animation. So I started working with different types of drawings, and this was a little bit more creative, but it's still, I think that's a really nice little video. Next. Okay, so this is Buzz Aldrin. He went to the moon with Neil Armstrong, and he's very related to the program. He would go by, and well, here's a little scope. Can you hear? Oh, wait.
I want to welcome you to the Space Architecture program at the University of Houston. Space architecture, it's not about architects doing space. It's about architecture in space.
The Space Architecture program is the only one in the world. It's really a combination of architectural approach to design and design process with engineering technicality.
So we don't do wallpaper. Space architecture is the logic that makes all these things comprehensible.
We look forward to having many more students interested in the opportunity to design integrated systems around people. We have the engineers, the architectural designers, the human factors people. It's very much like a small company when you bring together these engineers. We come out with design habitats, not just parts of systems, but a fully designed habitat.
Our students are, in every regard, full professionals. Houston naturally is where the astronaut are.
We hope to supply them with skilled graduates that have a systems engineering level understanding of the whole architecture, not just the design and the engineering.
What we do is not the kind of linear learning sort of thing. It's the kind of interactive. Let's pick a big challenging project to solve, and let's work together and do it, solve it.
And it's all about space exploration and working with habitats for people.
University of Houston, strong voice to be heard and to contribute.
All right. So, oops. Wait a second. Let me try to put full screen again. Okay. Is it sharing? No. Okay. Okay, now it is? Okay, got it. Perfect. Well, here, okay, so essentially that's an overview of the space architecture program at the University of Houston, which is the only master's in the world. So essentially being so close to JSC, which is the Johnson Space Center, we get into contact with people from NASA, different aerospace companies like Boeing, and say there's a certain problem that they want a multidisciplinary team of students to solve. So they gave us these number of variables. So I see them as variables. They can be called objective, goals, requirements. So there's different terminologies that define what a project looks for. And between a group of physicists, engineers, architects, industrial designers. So this multidiscipline is what essentially propels projects to move forward quickly. This is what happens in, say, technology in Silicon Valley. You have to have both design to optimize systems and the actual engineers to produce the actual product. And between both of them, you get both a very technically sound solution as well as a design optimized solution. So the International Space Station is a space where humans have been living for 20 years. And this was after the Apollo program. And this is where all the experiments are done for astronauts today. And this is what has kept the space industry moving. So, and we find that it's very complex piece of hardware, and it's all the greatest minds in the world have worked to maintain it up there functioning. And what astronauts do has to do with all these types of systems that are very complex. So essentially what space architecture looks to do is to grab all these different parts of a mission and simplify them, or get logic right so that the systems engineering is sound, and we can start communicating, kind of like how an architect would communicate with the structural engineer or the electronics engineer. We have to do the same, and a space architect would do the same, but with these other types of variables. And when you add design into the equation of STEM, I don't know, Karina was mentioning that, what you get is SpaceX type solutions. So what SpaceX does and has been doing is optimizing hardware, space hardware, leaning it down so that it's very cost effective and very functional at the same time. So that's essentially what the goal is, and taking this type of approach to any industry, I think, is very valuable. So there are moon settlements being proposed. This is a project to be done by Surge Plus, which is a space architecture company, with Icon, a 3D printing company. So then we would look a lot at projects that have to do with 3D printing. So when you go to another planet, you have to utilize in situ resources, because in a rocket you can only fit a certain amount of weight of things that you can take. It's kind of like if you would go to a trip to Antarctica, you can't take your whole house, so you have to take specific things. And how do you survive on that? So essentially 3D printing is a solution where you can just send robots or a 3D printer and build the actual places where the astronauts will live before they get there. So this would be kind of a solution to help them beforehand. And finally, there's SpaceX that is projecting to go to Mars, along with NASA, ESA, which is a European Space Agency. There's JAXA, which is a Japanese space agency. All these, and there's also the Italian Space Agency. All these different factors and players are working together to push humanity farther to another planet. But what happens? So we're projecting all these great solutions, but in the meantime, what is being generated is knowledge. So through science, through all these experiments of, say we're going to make a 3D printer for the moon. So while we're designing it right now, a lot of technologies are going to be developed and optimized. So and that's what the space industry does. It actually creates knowledge and it innovates. And if we get enough people involved from any field, then we can have even more innovations. So this is one of the projects that I worked on, which was essentially an artificial gravity Mars vehicle. So when you go to Mars, there's a third of the gravity that we experience here on Earth. So, and in space, while you're on the way there, you're going to have zero gravity. So your bones, they're not going to be pulled by anything. So essentially, artificial gravity is a concept that would generate, how the name says, artificial gravity. It's kind of like when you grab a pendulum and you put a weight at the end of a string and you start rotating it, it's going to create a centrifugal force and it's going to make you stand up. So this project, as a space architect, what you have to do is define the whole mission trajectory of how you build this machine in space. So we would think of that there would be this long rail, because you need a large radius, almost like 100 meters, and have the central propulsion in the center, and rotate it using ion thrusters. So this is one of the projects that I worked on, because if astronauts are going to be in Mars, then they need to complete their task quickly once they've set foot on the ground. But if they're a year and a half in space, which is how long it takes to get to Mars, then their bones are going to be very deteriorated. So you also have to think about the physiology of astronauts. And all these different factors come into play. So it seems complex, but it's actually, you have to find a way through systems engineering to make it understandable and to be able to transfer information from one person to another. So this is my, I said before, this is my master's thesis. Remember what I was showing about how I would look at bicycles and have this exploited view of systems? I applied the same thing to what I'm doing now. So you have a system as a whole, a project, and you have to think about every little component and how each of those components work together. And that's what essentially this is just imaging, but there's a whole investigation behind it. So for example, how do carbon fiber, reinforced polymer sheets work in certain environments, and how do you assemble these things to an interior frame? So this is the scale of, say, the size of a person, and this would be the astronauts in space. And this little assembly sequence. So obviously there's extremely more systems and little things that go into it, but as a space architect, you actually just idea how the assembly process would be, and then the nuts and bolts that's in engineering. So these are projects that take multiple years, but in the meantime, what you develop is research, and there's in academia, what you do is you just develop and you make publications and scientific papers. These scientific papers, what they do is they work to validate your proposal, and you get to collaborate with other types of engineers or scientists, PhDs, who are all also involved in the space industry. So it's this type of collaboration that can be done between universities, even universities in Latin America, which is one of our important topics today. How can we get students to participate in these type of projects? And I think a key important way to do this would be to think about a very long-term project and see how you can solve it. And out of that research, out of that collaboration, produce research papers or publications for conferences. And if you're lucky enough and you have a sound enough idea, then that paper can be published, and that's when you start getting recognition for your work and moving along in the industry. Oops. Okay, so now we're gonna talk a little bit more about what I'm doing right now. I actually kind of diverted a little from the space industry, but during my time studying there, this was the group project that I did with two classmates. We're essentially using augmented reality. We started to project orbital movements of different planets onto a 3D plane. So essentially with the camera, you can project the position of planets, and it's actually a very educationally instructive method. And yeah, it's very good to see. So there's that. And then once you understand how to work with these little technologies, these new programs, this was done with a program called Unity, you can start transferring these technologies to other fields. So think about architecture. So if you have new designs, you can project these onto 3D planes. So we do physical models in architecture. This could be a solution for instead of the student having to waste all your time and effort in building two little wood things, getting cut, spending nights not sleeping. You can have a 3D model that is actually very close to what the thing in real life looks like. So these are more of my augmented reality works. This is a Harry Potter song. But you can have projects at a scale in your table. And from there on, you can also project it in a one-to-one scale. So for, say, the real estate industry or people wanting to see how their house looks like before it's built and have an idea, you can either use virtual reality or augmented reality. So with your phone, you're essentially going to be able to see the interior of where you're going to live. So these are, I mean, with these types of programs, you just maybe just have to pay a small subscription and you're going to be able to do these types of solutions. So for space architecture, this is very important because you need to be able to visualize your products, your projects in a one-to-one scale. And in terms of collaboration right now with COVID, having augmented reality as a collaborative tool is a very, it's a topic that I've been looking into. So this is a small cabin, I call it the Sea House. The fun part about this is that it's on your phone, so and everybody has the capacity to use your phone. So the idea is just transmit this technology for everybody. And you can also look at urban scales. So if you're an urban developer, how can you project this whole series of buildings? So it's and have them projected at different scales. Okay, so. Okay, so this is gonna be, so essentially, okay. So you can see a one-to-one scale. Instead of having to build an actual prototype, before you build a prototype of a space station or a building, you can actually project it and see how it fares with your body proportions. So there's that. And finally, after this, my idea was to make it an actual business. So spin-offs of technologies, how can they be used now? And through an app and interface, you can actually see the apartments that you want to buy. And you actually click on them and you can project them on your living room. You can see the whole spatial distribution of your architecture projects. So this is one of the types of projects that I'm expanding on right now. Yeah, so make it quick. And it's also very fun to look at. I spent like a couple of hours just staring at the possibilities of this technology. So the idea is, as you project these new types of projects for space, in the meantime, you can start working on these technologies and apply them to other industries and even other countries. Kind of what Stephen and Robert were working on with the ventilator. Take that NASA technology and apply it to Latin America. these are the types of solutions that are very positive, and why I think the space industry needs to transition into Latin America and Ecuador, different countries. Sure. And yeah, so thank you.
Thank you so much, Leonardo Guzman. It's incredibly interesting how you can go from augmented reality, and actually, I think Walt Disney will be jealous. You know, he started animating a mouse and was able to go through the whole Earth. You started animating a bicycle and you're able to go through the whole galaxy. Isn't that wonderful?
Yes.
That's absolutely awesome. And in fact, with that mobile augmented reality app, you can actually make it work for real estate, for architectural design, commercial spaces, hotels, financial activities. It's just incredible. Now, I know we would love to be able to build things like you do with CAD and everything, but we can only go for Lego.
Well, that's a start. Hey, go play.
That's a start. And in fact, while Leonardo Guzman was talking about the International Space Station, we had a raffle here because it's our birthday, it's our first year anniversary, but the gift is actually for one of you. And Kendi Moreno is actually the winner for the International Space Station Lego. And so Kendi, make sure that you get in touch with Robert Ayon at the Guayaquil Space Society so that you can claim your Lego. It's actually 864 pieces of the International Space Station, and we would love to see it already built. So when you build it, make sure you take a picture and let us know. that would be absolutely wonderful. Leonardo mentioned that it would be great for different schools and for students to collaborate. And in fact, at the Guayaquil Space Society, there are several educational institutions that have helped. Colegio Javier, the Rice Space Institute, ESPOL, which is the Escuela Politécnica del Litoral in Ecuador, CEMPES, the Alliance Française, and UES, which is the Universidad Espíritu Santo in Ecuador, in Guayaquil. We like to send our thanks to the Consulate General of the United States in Guayaquil, Hotel Oro Verde, who welcomed us on November the 6th, 2019, for our first ever meeting here, and that was the founding of the Guayaquil Space Society. Also, would like to say thank you to the Mayor's Office of Trade and International Affairs in Houston, Texas, and Geoffrey Notkin from the National Space Society. In fact, Guayaquil is also the first space society in South America. Benacatur, that's the National Federation of Tourism in Ecuador. STOES help us out with simultaneous translations. Sister Cities of Houston and Universal Suite.
Karina, you're muted.
Don't tell me! If you had only heard what I told. Okay, so did you hear all the thank yous or not? What last part? Okay, I said thank you to Colegio Javier, Rice Space Institute, ESPOL, CEMPES, the Alliance Française, and UES, which is Universidad Espíritu Santo. Now, we also have to make sure we mention, because of all the help we've got from the Consulate General of the United States in Guayaquil, Hotel Oro Verde, the Mayor's Office of Trade and International Affairs in Houston, Texas, Geoffrey Notkin from the National Space Society, Olback Muñeton from Fenecatur, that's the National Federation of Tourism Chambers. Esto es, that helped us out with simultaneous translation. Sister cities of Houston and Universal Suite. Now, Leonardo mentioned about student collaboration, and so with that, I would like to welcome ESPOL students, Yanis Marquez de la Plata, Marcos Moreira, and Steve Marquez de la Plata, who are here to share some thoughts with us. So there's Steven. Steven, you can unmute your phone, and the same thing with Janice and Marcos.
Hello everyone, how's everything going? My name is Steven Marquez de la Plata, and I am a student from a very known university here in Ecuador called ESPOL, specifically in the degree of mechatronic engineering, and I am also a member of the Guayaquil Space Society. I will tell you a small summary of our project, the project that makes us win the NASA Space Apps Challenge 2020. StudentSat was born as an idea that seeks accelerators that support technological initiative to improve education in times of virtuality and eliminate social differences linked to this resource. It is based on the use of data stored in CubeSats, placed in orbit to meet the demand for access to information of the students from rural areas where the internet does not reach maximum coverage. With this, sufficient coverage and access to a database will be granted to places with a little access to this media in the region. With the lower cost of these spatial tools, potential solutions will be given to the problems of the fourth industrial revolution linked to equal access to information. So, that was our summary about the project, the StudentSats. I will talk to you about why it's important. It is important to develop ideas of this type, even if they are not implemented, because they open the way and create a precedent for other young people and professionals to have an extra incentive to participate in this kind of projects, because they see that there is international support and they notice that they are not alone. I also think that our idea is good because in this context of a global pandemic, it is extremely necessary to keep the social problems in Latin America and around the world under control, such as the declining education, in which we achieve an impact if we develop this kind of ideas.
Hello. ¿Sí me ven? ¿Sí me escuchan? Hello.
Te escuchamos, Marcos.
Pero sí me ven. Tengo prendida la cámara, no sé si me ven. Hello. Bueno, voy a suponer que me están viendo.
Yes. Sí te escuchamos.
Okay.
Puedes hablar.
Thanks so much. Hello to everyone. I'm Marcos Moreira, I'm a student from ESPOL in computer science engineering career, and I participate in the NASA Space Apps Challenge in 2020. I was very excited because we can win this contest. No sé si puedo decirlo en español, disculpen. ¿Aló? ¿Sí me escuchan?
Lo puedes decir en español y de ahí te registras al CEN para aprender inglés, ¿te parece?
Sí, tranquilo. Estoy muy nervioso, la verdad. Es la primera vez que hablo aquí en un webinar tan importante como este. Y en serio que no tengo tantas palabras para describir toda la emoción que pude experimentar ahorita y en el concurso. Porque en serio es la primera vez que puedo terminar un concurso de tal magnitud y ganar un concurso de tal magnitud representando a una institución de gran magnitud. Y es por eso tanto mi nerviosismo ahorita, que es sencillamente impresionante el esfuerzo que nos conllevó a mí, a Yanis y a Steven para poder terminar e incluso poder ganar. O sea, claro que mi experiencia pasada en el concurso en 2018, donde conocí a Robert, pues me ayudó bastante y desde que he trabajado ciertas cositas con Robert, pues me ha ayudado, o sea, mucho, no solo en este concurso, sino próximamente, muy posiblemente en mi carrera, en mi vida profesional. Y bueno, quiero pues agradecer a los chicos que me han acompañado y que se han esforzado bastante a pesar de todo lo que pasó. Pudimos terminar y afortunadamente ganar. Aunque claro, curiosamente en nuestro concurso nosotros enfocamos el tema de la, como dijo Steven, sobre el tema de la baja internet, internet de mala calidad aquí en Latinoamérica. Y eso es algo muy a tener en cuenta, porque ahora, entre otras tecnologías, internet es como el agua de la economía. Y si no tenemos una buena internet, seremos poco o nada competitivos con la nueva normalidad. No por el COVID, sino por la nueva revolución de la industria del 4.0. Así que me siento muy agradecido con el Guayaquil Space Society, con Robert también y con todos mis compañeros. Muchas gracias.
Muchísimas gracias, Marcos. Thank you so very much. Y ahora tenemos a Nalo. Now we have Janice and Marquis de la Plata. She's going to be sharing with us.
Well, in my experience, I believe that the true challenge of the group was to build it in itself, to propose a solution to a current problem on the planet. Sometimes we believe that we don't have no capacity or talent to achieve something, and that is why many ideas are not made now. For this reason, I invite all adolescents who are interested in the subject to take a step and show their solution ideas to the world. Throughout the process, we were also accompanied by mentors from the Guayaquil NASA Space Challenge. So trust and compete in the next challenge. I recommend. Thank you.
That is absolutely wonderful. During our year, we've had several great guests. We had Ellen Baker, who was actually here in Guayaquil, and she was actually at the Hotel Oro Verde. In fact, we are here at Hotel Oro Verde right now. Centro Ecuatoriano-Norteamericano had Ginny Andrade share with us. Miguel Ayala with Exodus, Oscar Garcia with InFlight Global, Benjamin Rosales, Fernando Mancero, Riley Mike from Sugar House Aerospace, Mateo Alvarez from Axiom Space, Stefan Recchi from Gen Space, Molly Mulligan from Space Commerce Matters, Kali Yakala from Space Nation, Robert Feuerbach from Zero G Launch, and many more to come. The internet is actually being able to keep us together and be able right now to welcome several of you from some other places that are not in Guayaquil. So we're very thankful to that. We will have a time for a few questions, but I would like to welcome Francisco Sweat the screen. In fact, again, going with dates, 24th of November is today. In 2 days, it's going to be Thanksgiving in the U.S. And Francisco Sweat was a former Secretary of Finance of Ecuador. He has a master's degree in public affairs with Princeton, a Bachelor of Arts from Wesleyan. Actually, his relatives can be traced down all the way to the Pilgrims and the Mayflower, and so we welcome Francisco here with us. He's a column writer with Diario Expreso in Ecuador, with El Montonero in Peru, with Latin American Advisor. He's also a member of the editorial board of Diario Expreso, and he's the dean of the School of Economics and Business with Universidad Espíritu Santo. Thank you so much, Francisco, for being with us, and he is a founding member of the Guayaquil Space Society.
Thank you, Karina. I hope I'm in the middle of the screen here. Okay. Indeed, this year has gone very fast. I remember last year being together at the Oro Verde site for the launching of the Space Society, and how good we felt about the incoming activity of something that otherwise is considered to be a dream, something unusual, and certainly for a country like Ecuador, it is a brand new experience to think of the stars, the planets, the galaxies, the constellations of the universe, to go back to Einstein and then quantum mechanics and everything that goes around in the science of the universe, to think about the future of this planet, and not talking about the next 5 years. I'm talking in geological times, what it means as, let's say, this planet comes to an end at some point. This is the domain of the space, and it is in the interest of the Space Society. I have been very well impressed by all the different presentations that we've seen today. Each one of them has added to our current knowledge of the science, of the experience, of the nature of the activity that goes on, of the exploration of the cosmos. And we can only think of the kinds of new findings, new experiences, new opportunities that come from being knowledgeable about the space. In Guayaquil, we have to be thankful for Robert's activity. He has been a pioneer, and I mean a pioneer. He has been an initiator. He has the tools of the creator to put together an idea in his mind because he loves the subject, and then to formulate what he wants to do and to pursue that dream. Dreams, ideas, which are always lodged initially in the mind, eventually become part of reality and they materialize. And I salute Robert in this first year of the Guayaquil Space Society as it has been put together. And I think that it is only good that we mention that, because he was the one who brought me into this matter, not because I hadn't heard of this. I did have a chance to watch the landing on the moon. So I mean that's how old I am now. But the fact is that I have followed the Mercury and the Apollo programs, and then all the rest, the shuttle, and now SpaceX and all the new private initiatives. But he was instrumental in saying, let's do something here in Ecuador, in Guayaquil. Let's be the pioneers. We have the talent, and we have a competitive advantage, which is giving us by geography. just think of what this world will look like in 20 years, 25 years, another generation, about air transport, how distances will be shortened, how the fact that we are located where we are means that we will have a competitive advantage, natural, God-given, geographical competitive advantage. And what it means for us in just being there and being activists and being a part of the group of highly intelligent people who are thinking these things through and putting together our own private and local talent. Our young students, when I see the young folks from ESPOL, from the Polytechnic School, I can only be proud of them. As a Guayaquileño, as an Ecuadorian citizen, and as someone who shares with them the passion for something that is new, something that is different. And remember, it is a matter of not just one generation. The posts will pass on. You will get it, and you will be excited, and you will contribute to this trove of knowledge that means space. What we hear today was science fiction back 10 or even say 25 or 30 years ago. But now it's reality. Just think of what you will have in your hands to look at and to do when you look like me. So anyway, be good. Happy birthday to the Guayaquil Space Society. My warmest regard for Robert. Karina, as always, you are way special and manage masterfully a show like this. Thanks a lot for all your attention. Thank you kindly.
Thank you so much, Francisco. And in fact, whenever we can, we are going to be able to go back to meeting all of you live, hopefully here at Hotel Oro Verde. In the meantime, I just want to make you guys jealous. Hotel Oro Verde made us a cake with the galaxies. Isn't that absolutely beautiful? So a big round of applause for Hotel Oro Verde. Now, Steven Gonzalez, Stephanie Brooks, she worked with you at GHP, and she says hello. She wanted to congratulate you on this, and we do have some questions. Jaime was saying in 1969, Apollo 11 took 4 days, 6 hours to reach to the moon. How long does it take to reach the moon? And he wrote 2020, but I'm going to change that to 2021 because in 2020 we can't go anywhere pretty much. So Stephen, what would be the answer to that question?
The short answer is about the same time. We have technologies that are being looked at for Mars. There is a wonderful scientist here by the name of Franklin Chang Diaz, who has a company also down in Costa Rica. He's coming up with some propulsion technologies that would decrease the time to get to Mars. But right now, all the plans for the moon are using the same type of propulsion technology that we used the first time. So it's about the same amount of time as when we went back in the 60s.
And I have something to add to that. Also, when you think about orbital mechanics, which is the whole physics behind the movement of bodies in space, a lot of the physics stays the same, which are Kepler mechanics. What changes is, it would be how Steven says, the propulsion systems, but up to now, we've been using almost the same type of fuel. So I guess the difference would be about a day if we think about the advancements of technologies, but that's not that much. Essentially the same.
Thank you so much, Stephen and Leonardo. Now, Jaime also has another question, and I wish I could tell you his last name, but he only says Jaime there. But he says, can the International Space Station travel slower than 27,600 kilometers per hour without falling significantly down to Earth? Steven, your turn.
So the question, so every time it decreases speed, it will lower its orbit. So the lower it gets, the more drag it has, the more energy it will take to go back up. How far it can go down, that's a great question. I do not know how far it can go down, but I know that they try to, there's a safe range that Mission Control is always looking at to make sure that the space station does not go below that orbit, and that would mean below that speed, because then it would potentially put the crew at risk. So yes, it can, but not very much before it starts getting too low of an orbit and it could drag it back into the Earth.
Thank you so much, Stephen. Now, Stephen, you mentioned that we can have these human-powered ventilators. Now, can we use research in space, research in zero gravity to study, for example, the behavior of viruses and bacteria?
Absolutely. There was one company during the shuttle time frame that was looking at the salmonella virus, and they put it up into space, and they found that in space, it became much more aggressive. And so because of the way it behaved in space, they were able to come up with a vaccine that they would not have discovered here on Earth. And so I know last I knew that they were going through the process of getting approval for that vaccine to be able to take care of salmonella. So yes, in space, because of the microgravity environment there, it does allow things to behave differently. But then again, every day, even the astronauts, the way their body behaves gives them new insights into things they may be able to do on Earth. In the astronaut's body, a lot of times, the way their blood behaves mimics leukemia. And so if they can understand why is it that when the astronauts come back to Earth, they don't have leukemia, what is it that the body does to respond by itself, then they may be able to find a cure for leukemia. There's also other technologies that we're looking at, bone loss. And if they understand how to reduce the bone loss in the astronauts, they can help the elderly with bone loss in their bodies. So yes, absolutely.
Mm-hmm. That's awesome. Now, Stephen, when we were told Stephen Gonzalez was gonna show up, and he had worked for NASA for 32 years, I particularly imagined somebody who looked like I don't know, maybe 90. And did you go to space and were your cells changed by space, or do you purposely dye your hair white?
That's too sweet. No, they did not try to test out the idea of the faster you go, the younger you get, but that would be fun. No, this is all natural. Thank you, Karina.
Now, Andres has another question, and it's for you, Stephen. If you were to go back to college right before graduation, what would you do, or what steps would you take, knowing what you know today, to get your feet into NASA's door?
Before I graduate, that's a great question. So number one, now I would have done an internship with NASA. So I would spend more time at school, because I tried to rush through school and not do any internships. I didn't do any co-ops, so I would have taken more time to be able to make sure, because now NASA only hires through those programs, through those college programs where you get to work a summer, you get to work a semester in NASA. The second part is that now with everything going on, I would have looked for opportunities in other space industries. I had one student that I was mentoring who wanted to get to NASA, but I told him with what he wanted to do, he was better going to either SpaceX or Blue Origin, Jeff Bezos' company, or Virgin Galactic, the company that is owned by Richard Branson, and there's so many other companies. So if I were a student today, I would look at some of these other companies, some of these fast, smaller companies, because there is an opportunity to do more in some of these companies than you could right away at NASA. So I would, if I were a student all over again, I would really expand my scope beyond NASA.
That's great. In fact, I heard somebody say once, if you really, you have a choice. You could either kill yourself studying for 4 years and breeze through the rest of your life, or breeze through college not doing anything and then kill yourself trying to survive for the rest of your life. And it's actually pretty simple once you put it like that. Yes.
You talked about, there's also the whole idea of entrepreneurship, and a lot of people don't think about how you can start up a company and not have to breeze through college. You just create a company, I don't need to go to college. From what I shared today, that would have been a third option I would have looked at when I was in college. I would have tried to figure out how I could be a part of a startup while I was in college. If there was an opportunity to be able to, while I'm in college, but I have the safety of being able to work on my degree, have a place to stay, live, not have to worry about living off of noodles for the time, then I would work on a startup while also trying to get my degree.
That's awesome. Thank you so much, Steven. Leonardo, somebody with Paul Del Valle asks, what app do you use in order to create the models?
Yeah, well, I do the modeling in Cinema 4D, which is a 3D modeling and animation software. It's kind of like Blender. I don't know if they've heard of it. But essentially it has a really good user interface that you can volumetrically shape things without many polygons, which in technical terms, that's how you make 3D models less heavy. So it optimizes the functionality. But the augmented reality in itself, I do it in a program called Unity with diverse plugins. So Unity is used, I think, a lot in the aerospace industry. And also, right now they're using for virtual reality. So it's Unity. Yeah, that's essentially one of the main ones. And it depends on the type of plugins that you want. So, for example, Google has an AR plugin that's called Google AR, and Apple is also getting into this technology, because Apple is trying to advance on their augmented reality functions for iPhones, and also projecting to have glasses. So kind of like, so you kind of start projecting where industries are going. So in terms of augmented reality, Apple is looking to take out glasses. I don't know, they're saying maybe next year or the year after that, but it's gonna be soon. And it's going to function essentially like an Apple Watch. I was having this conversation with a friend, because for glasses, so you can think about projecting a 3D model onto the glass, and then it's kind of like sci-fi where you're going to see people's faces or seeing a building, and it's going to tell you some lines of things. But what happens there is that you have to take into account the movement of the pupil, because the human eye, so the software, essentially, they have to look at your pupil and take the movement, and that's how you'll get a good functioning 3D model. So it is sci-fi, but we're very close to being there. There are already the HoloLens, which is augmented reality glasses, and there's also virtual reality VR headsets that are being used a lot. They're called Oculus.
Wow, that's incredible. Well, we'll have one last question for you, Leonardo, and one last question for Steven. Leonardo, what is UI or UX designer?
Yeah, so UI UX is user interface and user experience. UX is user experience. Essentially, how design has to do with human systems interactions. So how is a certain space or a certain object, a product developed for that the human function is very straightforward. So as a designer of digital software, you have to think about how the user experience is going to be. That's like when you look at apps, how are they user friendly? And that has to do also with the user interface.
Great, thank you so much. Now, a question to Stephen. This is from Domenica Freire Guevara. In this 20th century, we are going through a crisis in cosmology in which astronomers worked with NASA's Hubble Space Telescope in combination with W.M. Keck Observatory's adaptive optics system to observe 3 gravitationally lensed systems. Astrophysicists had several highly precise methods for determining the Hubble constant, and these methods keep returning different results for an unknown reason, and scientists think it could be some unknown property of dark energy. Has there been any recent discovery about the matter? You thought it would be a very easy question. Well, try to read that.
That's an amazing question. Unfortunately, I'm not the right person to answer that. So, there's a lot of incredible research being done in dark matter and dark energy, but I don't know what the latest is on that. So I'm sorry, Karina.
Okay, well, since you didn't answer that one, Stephen, then I'm going to ask you what Daniela Jimenez is asking. How is computer science engineering related to space jobs? She's interested because she's a computer science major and she's passionate about